Write the inverse relation of each of the following functions. So we have f of x is equal to 1 minus 3x. So let's start by saying that that's y equals 1 minus 3x. And then I'm going to interchange x and y. So I have x is equal to 1 minus 3y. I want to rearrange that to make y the subject of the formula. So I can rewrite that as 3y equals 1 minus x, and then divide by 3 to get y is equal to 1 minus x over 3. Then replace the y with f minus 1, so the inverse function of x is 1 minus x over 3. At the end of the question, it says for each part of the above example, graph both the function and inverse function on your CAS or graphing software. Add the line y equals x to your graph. Try to use equal scales. What do you notice? So for this first one, I have done the graph on Desmos. The red is the original function. The blue is the inverse function, and the green line is y equals x. We can see that the blue and red lines are reflections of each other in the y equals x line. So somewhere like that gets reflected across the green line to this position here. Note how they actually meet on y equals x, which you'd expect if they were reflections. So let's move to the next part. So we've got y is equal to x cubed plus 3. Interchange x and y. So we've got x equals y cubed plus 3, and now we want to make y the subject. So y cubed would be x take away 3, and then y would be the cube root of x minus 3. So the inverse function should be the cube root of x minus 3. So here's the function and its inverse, graphed on Desmos graphing calculator with y equals x, and it should be quite clear to see that the red, which is the original function, and the blue, which is the inverse function, are reflections of each other in y equals x. I'm saying that this is the original function and this is the inverse function, but of course they're actually inverse functions of each other. So moving to the last part of this question, this one actually does require logarithms. So we'd say y is equal to 10 to the power 2x. Interchange the x and y, and we get x equals 10 to the 2y. So we want to make y the subject. The inverse of 10 to the power of is log to the base 10. So log to the base 10 of x is log to the base 10 of 10 to the 2y. Now there's a log law that says that on the right hand side there, I can bring down the 2y, which is log to the base 10 of 10, and log to the base 10 of 10 is 1, is another law. So we get that y is equal to a half log to the base 10 of x, or log to the base 10 of x over 2, and so the inverse function is a half log to the base 10 of x. Once again, looking at Desmos, we can see that the function and the inverse function are reflections of each other in the line y equals x.